In this video, we present See Me, See You, a lightweight system for discriminating user touches on a camera-based tabletop. Common camera-based technologies such as DI or FTIR are unable to tell which user is producing a touch. Without being able to distinguish user touches, tabletops may not be able to support multi-user applications. For example, the paint program in this demo. One user is drawing with a selected color. A second user attempts to select a different color, however, the action also changes the first user's color. This is undesirable in multi-user applications. Let's look at another application. Two users, A and B, are playing a tic-tac-toe game. As the game moves on, player A gets distracted, and player B is able to make a move for A. In a tabletop system that can distinguish user touches, this situation can be detected and prevented from happening. We have designed a lightweight solution to distinguish user touches, using the finger orientation extracted from the hand shadow. We collected finger orientations from 8 participants in 3 positions around the table. We used this data to extrapolate to other positions and to train our prediction model. In this graph, the ranges of each position are quite different. The standard deviations of each range, represented by the shorter line, are all very narrow. Using finger orientations, our tabletop system is now able to discriminate users' touches. In this paint program, 3 different users can interact simultaneously with the system without affecting one another. Similarly, in the tic-tac-toe game, our system is now able to detect which player is touching and enforce game rules. Player B can no longer make player A's move. We evaluated the accuracy of our technique with 4 different tasks. In the first task, users performed a simple point selection with their right hand. In the second task, users rotated a widget with their right hand. In the third task, users were allowed to rotate with either hand. The final task required users to scale with both hands. The results show that our system achieved very high overall accuracy in all conditions, even though participants received only minimal training. As an enhancement to our technique, we developed the Position Aware Cursor, or PAC, to allow for error recovery. We demonstrate PAC with 3 users at set positions. However, PAC can easily support additional users. As shown in the video, as a user touches the table, her position is predicted immediately based on her finger orientation, which is represented by the arrow. PAC shows 2 other possible ranges. In case of a prediction error, the user can adjust her finger orientation and select a different position. With this design, a user is able to perform a correction if a prediction error occurs. Our second enhancement is called Position Avatar, which allows users to log in, log out, and maintain a user profile while interacting with the table. We implemented a paint program with the Position Avatar. After logging in, 2 users can simultaneously interact with the application. They each select a color and line thickness. As shown here, the left user is able to drag his avatar and move to a different position, and his color and thickness selections are moved as well. This design allows users to move around the table but continue interacting with the system with the same user profile. Finally, we demonstrate a Mahjong solitaire game. After logging in, each player can start selecting tiles. Once 2 identical tiles are selected by the same player, they will disappear. Our system is able to keep track of user selections and award points to the correct player. This application demonstrates our technique and makes this kind of competitive gaming system easier and more fun. In conclusion, See Me, See You is an effective, flexible, lightweight, and highly accurate approach for position awareness on camera-based tabletop systems.